Hello. Today we have binarysearch.com weekly contest 43, and it will start in a minute. It's pretty soon. I guess that's all you have to know before the contest starts, actually. So yeah. Also, so we will have a stream afterwards, and this video with solutions and screencast will come out a bit later because stream is immediate and videos take some time to process. And also you can join our Discord. Just, friendly reminder. Because obviously I can answer questions faster here. So yeah, let's go. I will code in Python and let's see how it goes. Yeah, it takes some time to refresh the page, but not too long. Soon it will load. Okay. Huh? I guess. I think I understand it correctly. Not exactly sure if it's the song. Oh, okay. Oh, damn it. Okay. Well, Hmm. Or maybe it's this way around. Hmm? No, that's okay. Okay, then I have to see. Basically, what I'm trying to do is whether there was a reversal or not. Originally, I want it ascending. If it's not ascending, so this means that we are descending. Wait. If else, then we want it ascending. This means that we are not ascending. Then we have to override place when we start. We want to say like now we want it descending. If start is already present, then we want to return false. Otherwise, we want it descending for now. If it's ascending, then we have to like switch right endpoint and say that now we want it ascending again. So it's ascending, then descending, then ascending. Is it because I need like not to have any precision? No. I don't understand. Here we clearly can reverse 6, 7. Initially wanted ascending. And it says that it's ascending. If it's not ascending, then we want to start reversing that portion of a list. We want to go descending. See, we first want to go ascending. Then at some point, we may encounter a place when we start going descending, and then we go ascending again. I don't understand, like, why isn't it working? Number 10. Zero, 1, 5. What the heck? How we end up with 0 here? How is a... God damn it. Of course. What? Oh. 0, 1, 2, 3, 4, 5. Do you want it like that? Oh, yeah, I don't. Just forget about it. Not sure about the syntax. Oh, okay. Damn it. They index people from 0. Okay. Wait, isn't it classical? Okay. We guaranteed anything about them. Anyways, or actually we don't care. Like, so if it's 0, yes. Oh, this way. Right. Um, okay. Um, something like that. Small than m. Plus one. Then what am I doing? No, actually, I want this to be the first key, right? Okay. Well, on the other hand, this now I can do it like that. However, there are drawbacks as well. Yes. Okay. This should go that. Huh? Okay. I can do it like that as well. Now what? Is it because I did not do it like that or what? Right. Uh, oh, how am I supposed to deal with that? I did not think about it. I did not think about it. It's bad. I actually didn't even had this in this. Okay. How to deal with negative numbers. How to deal with negative numbers. Basically, we are okay with negative and with positive, right? Huh? Oh, that's really annoying, actually. Oh, stupid. Yeah, it's not done great. Oh man, I don't even know if it's going to fix it. Oh, is it like gap zero? it does not count. Heck is that? Oh, we can't also. What the? Okay. Just gets more and more annoying, to be honest. Mm, Something like that should work. I hope not. Really annoying. I hope I'm not missing like anything. Why is it? Oh my, oh my. I don't think it actually makes a difference, but how is that still here? Was the initial approach correct? I don't understand. No, it should not be correct. Like, okay. Here's -1. Here is -1. Here's +1. Here's. Okay. I guess it's like get 0. Here we actually want get 1 and get 2. The heck is that? How is it wrong? Wait a second. Wait a second. Oh, okay. Oh, I don't understand. They asked for sort. Is it because we don't? Oh man. It's the worst problem ever. We also have Q2 to upsolve. What the hell is going on? Wait a second. Why am I getting like this, actually? I'm not supposed to be getting this, I think. Yeah, I really think I'm not supposed to be getting this answer. Like, 1 is positive, 2 is... What's going on? 110, okay, because the value is 2, okay. And 001, okay. Then 1, 0, 1, 0. Can we also have, please, get 0? Last number should be the product. So the product is -1 here, because it's like 2, 1, -1, and you have -2 actually. How on earth did we end up with value of 1? I have it here. Get 0, 0 again? How is it possible? I never go to the same cell again. Or is it because visited? Okay, let's just, I don't know what I'm doing. Heck is that problem? What? Oh man. This is terrible. We will pretend that this never happened. Because I am terribly annoyed. Have like from every endpoint such a mess. Oh, come on. I even pressed it. Seconds. So, well, actually, no, it should be like. We already. What the heck? How kind of problem is so annoying? Apparently we won't finish in top 10 today. Basically, our only hope at that moment is that some people get very unlucky with second problem and can't figure it out for a long period of time. Oh, I don't understand. Well, literally in place like every possible single starting position. It can be only one of 4 edges, and 4 edges we will just do what we want to do. Or is it because we don't pop? I don't understand. It should be at one of the 4 edges. Like second, for whatever reason we get 0. 0 is not correct. But how on earth do we get 0? I just don't understand. Do we manage to visit it like wrong? Yeah, but okay, but what about like other things? Second. Oh, is it first? Oh my god. One from me. Honestly, what do you want? 1, 2, 3, 4. Zero, 3 is the largest one. 0, 1 is the largest one. Actually, why 0, 1 is the largest one? Am I an idiot or something? Oh. What happens here if you want? Yeah, I just want to quick fix it and hope that it works. I don't remember what was the issue with that problem. Okay, thank you for reminding me. Here, like this part is increasing, decreasing, and we swap and we sort. Is it because here I also want -1? No. Okay. Maybe something. Okay. Oh, that was terrible. Whoa. Yeah, but anyways, it was terrible. Like, really annoying. It happens. Okay, it happens. We just did everything wrong, you know, it happens. Let's walk through problems. Don't really need chat. Okay, so here we are given a two-dimensional list of strings contacts. Each element context I represents a list of emails for the contact I. Contact I is considered a duplicate if there's a j with less than I, such that contact j shares a common email with I. Basically what we do, I just said like, we'll create a counter for the answer. I'll also maintain the set of emails that I already seen, because like this condition requires me to check set inclusion quickly. So I create an empty set, and then I just say like, okay, let's insert. Like when I see a new email, it's also like a set. I have two sets, like emails that I already seen. So that's seen. And current. Also. And whenever these two do not intersect, and in Python you can chat set intersection like that. In C++ there's std intersects or set intersection, something like that. I mean, you can Google it. So it's not something like Python specific. If intersection is empty, then I increment counter because this contact is unique, and I add all of this here. And in Python, you can do like just this. In C++, I guess you insert with a for loop, something like that. Then you just return the counter. So yeah, something like that. In problem, the second problem, we had numbers. Numbers were some points like 1, 3, then 9, 8, and I guess 2. So just in case I added two sentinels like plus infinity, negative infinity, positive infinity. And let's say like our array should look like this. It's increasing, then it's decreasing, then it's increasing again. Like if array looks like this, then we can take this part. Like there should be only one such part, because if there are two, then we clearly can't reverse anything. If there's one, then we want to reverse it and then check whether the array became sorted. And also we had problems like, what if we have several twos here? You want to include that too. And what if we have several trees? You want to include that tree as well. This condition corresponds to extending left as long as there are equal elements. This condition corresponds to extending right as long as there are equal elements. And this is just how to compute left and right in the first place. So flag corresponds to whether we're going up or down. If we go up, then F is true. When we see that we started to go down, we set F to false, and then we want to check like for the other condition, for the other change of movement. Once we begin moving up again, we set F back to true. That's it. If you and we record L and R. If L is not -1 when we start going down again, so like in this case, we start going down again, then something went wrong. We can't fix this array. It's too many different directions it's going. Something like that. I originally forgot like that part entirely, and I also checked this wrong. I don't know what's up with me today. I just not really focused. Anyways, here we want to view our people. Like pretty similar problem was easy last week, I think, when or maybe 2 weeks ago or something, or even 3 weeks ago, like buildings and the ocean. I remember something like that. Difference here is we're only interested in like a fixed width window. So we maintain just it with std multiset. We can do it in Python. You can do it with counter, I believe, or maybe counter is not sorted. Anyway, like you need a container that is sorted. I'm also not sure if it's the intended way. Like maybe it's too slow. Maybe there's a linear solution because this is linear rhythmic. So n log n. But anyways, we just check that A is answers. So what goes on something like this? We have, yeah, let's go over this example. Originally, our window is like empty. When we encounter new element, we say like, well, actually it's window is empty, so we append it to the result. And I use set to maintain answer because I don't want to sort them manually later. I can just construct a vector from 2 iterators and it will be already sorted. So then I like insert 9 here, and I check 4. 4 is smaller, so we just insert it here. Then I insert 7. I actually check like 7 is not as bigger than everything, so I insert it. And then I say like, hey, this is window of size 3, so I erase element and I know what to erase because it's the element that I seen k times ago, k seconds ago. And then I see 7, it's not strictly greater, so I insert it, erase last, first inserted element, then I say 8. 8 is great, so I add it here. I insert this. Then I see 9. 9 is greater than everything here, so I go here, and insert as the one that was inserted. Erase the one that was inserted first, something like that. I'm not exactly sure what is the supposed way to do multisets in Python. That's why I switched to C++. Here, you know, pretty similar problem when everything is positive is well known. It's priority queue. You do kinda BFS on the table. So you first sort A increasing, then you sort B increasing, and then you start BFS from here, I believe. So like one single element, here everything is positive, and maximum product is clearly here. Next max product can be either here or here. So you go here, here. Then you check like what goes on here, what goes on here. Because they are in priority queue, you can select the maximum in all of one and erase it in logarithmic time. So you say like, okay, this is the maximum, and you go like this. And like what I did is terrible. Now that I think about it, we can do it like much better. But like if you don't know about numbers being positive, then you kind of want like, what if best value is like here you have 1 and 1, but here you have minus 100 and minus 100. Like multiplying these two together gives a positive product. Or maybe like here is not 100, but here is 100, and here is like 1. Then multiplying, wait a second, and here's minus 10. Then multiplying these two together gives the biggest product. So I decided, let me just start like from every of the corners. Just start my BFS like middle to source. And I also say like which ways I want to go. So these are starting points. And I also maintain visited because like or in the original problem, you can't go to the same vertex place twice, but here you can, like from here and here. I also maintain visited, and I maintain them in the set because pair does not have like default hash. And also it gets really annoying to check because you have to make pair. Not sure if the curly braces work. They did not work just recently within the compiler. So that's what I did instead. And like this part, also I store like which ways we want to go. Do we want to go increasing index of A and decreasing index of B? And I compute like new indices that I want to go to. I check that they are valid. I check that they are not visited. And if so, I mark them as visited and place into priority queue. And the reason like why you get this kind of function, like I think that what is the derivatives of the product? Actually, why this works? No, I guess like if you take any slice, any horizontal slice, right? Take this row. Where is the max element in it? Well, clearly on one of the edges, because like A is fixed, so and Bj varies, so it's a linear function. If you plot it in three-dimensional space, it's going to look like this, right? And it may look different for different AIs, but you don't care. Like on every horizontal segment and on every vertical segment, maximum is at some of the endpoints, right? So if you take like all segments, maximum is still going to be on one of the endpoints. But it means that maximum is like on one of these two segments, and then you apply your theorem again. It's in one of the endpoints. So that's why like going from all endpoints work. Man, that was hard. I did so many errors. I'm not even proud or anything of being in top 10. Just look at this, like people solved everything like 3 times faster than I did. Well, I mean, these two are kind of smart, but then like everything here was totally beatable. Whatever. Sometimes it happens, it's just not your day. Yeah, I mean, this guy was third last time, right? I think so. Yeah, finalist, okay. Yeah. So yeah, things like that definitely happen sometimes. I don't know what to say, like I terribly I did everything wrong, but actually Joffrey also got wrong answer here, I suppose. Yeah, I was not practicing much this week, so maybe lack of practice shows. It's not great. Yeah, I think we just have to practice more with Python and that kind of interview questions. But it was like really annoying, two problems where you have to like carefully do something. That's not what I typically do. Oh, by the way, can I filter by friends? How do I go to the first page of the friends? Ah, it shows me, okay, because I'm okay. I'm not my own friend. So yeah, actually, my friends are not doing particularly well this time around. No, I mean, like solving 3 questions is definitely good, right? So they're mostly in top 100. On the other hand, like, we have, I believe, 500 participants. Oh, less than half solved first problem, which is kind of unfortunate. Maybe some people just forgot about it. I mean, yeah, so some people just did not submit, registered for the contest and then did not like submit. Yeah, but this is one is really annoying. I'm impressed with that guy. It's actually real smart. Like if you can get this, then it makes more sense to make this because it's worth more points. So it's a great strategic decision. And also, definitely should add Lara to my friends. Yeah, that's a bit embarrassing. Like, you know. Yep. Let's go find Larry. I guess Larry, I mean, if Larry writes in Python, it must be really annoying to do all of this, like which way to go. Yeah. Yeah, this is definitely fun. And it's like, yeah, okay, relax, chill. I mean, that's a great point. That binarysearch.com is mostly for fun. I learn a lot. And it's really, people are real nice here. What can I say? I earned the badge. Wow, because yes. So yeah. Anyways, we're not talking about. Sorry. I wonder if it's like terribly wrong. But I feel like most of these solutions were intended, apart from them being terribly implemented. Yeah, something like that. Actually, let's get back to our main page. I mean, so we'll stream very soon. We have only 7 minutes remaining. So we'll find out his solutions soon. Actually, I see a delay. Interesting. Something went wrong. Okay. I think it's something to do with my internet, so I guess I will end this video here. And yeah, that's it. So I guess thanks for watching. Join our Discord server if you have any questions remaining. And I'll see you tomorrow, I believe, with Code Chef contest. I think it's Code Chef. Let me quickly check. My schedule here. I think we have Code Chef like lunchtime, I guess. Cook off. Okay, cook off. Yeah, cool. So at least we finished in top 10, which is kind of not bad. But to be honest, it feels like terribly bad. But it happens. It happens. I'm assuming we are not getting plus 100. Yeah, if you were wondering. Definitely not something we get in today because it was just not great, not great. But still, like Larry has a good point. binarysearch.com is mostly about having fun and learning algorithms together. Definitely join this platform if you want to find your friends, learn algorithms together. And definitely join our Discord server because it's a kind of, I mean, it's a good server, right? Because there's me. There are also like 100 people. Some of them are ready to help you. So yeah, definitely join. I will add TLE like tomorrow, I guess. And it will become even better place to be. So yeah, thanks for watching and bye-bye. See you next time.